Close your eyes now. Just breathe. Let your body settle into wherever you are resting tonight, into the softness beneath you, into the quiet warmth surrounding you. There is nowhere you need to be. There is nothing you need to do. The world outside can wait. Everything can wait. Tonight, we are going somewhere very far away. Imagine, if you will, a hillside, a gentle hillside, somewhere in the countryside, far from the glow of any city. It is night, a deep, still night, the kind of night where the air smells faintly of cool grass and distant pine trees, and the only sound is the very soft whisper of wind moving slowly through the dark. You are walking up this hillside, slowly, unhurried. Each step is soft and easy. Pause. And as you reach the top of the hill, you stop and you look up. The sky above you is extraordinary. You have perhaps never seen a sky quite like this one. Without the lights of towns or roads anywhere nearby, the stars are uncountable. They stretch from one edge of the horizon to the other. Thousands of them, tens of thousands of them. Little points of silver and gold and faint blue-white, scattered across the deep navy darkness like grains of sand on a shoreline that goes on forever. The Milky Way stretches above you like a river of soft light. A river of stars so distant and so many that they blur together into a gentle haze, a pale ribbon flowing from one side of the sky to the other. Pause. You breathe in the cool night air. You are very comfortable here, very safe, and you simply look. Long pause. Somewhere on this same hillside, not far from where you are standing, there is a building. It is low and white and round, and from its center rises a great dome. A dome that opens to the sky like the shell of some enormous, peaceful creature welcoming the night. Inside that dome, a telescope waits, a beautiful instrument pointed upward into the dark, its lens collecting light from stars so far away that the light now reaching it left those stars before your great-great-grandparents were born. This is an observatory, and inside, tonight, someone is listening. Pause. Not just looking, listening. Because beyond the light that our eyes can see, beyond the visible glow of stars and galaxies, the universe is also full of sound. Not sound the way we hear sound here on Earth. For space, of course, is silent in the way we usually think of silence. In space, the air that carries our voices does not exist. And yet, the universe is humming with something, with signals, with waves, with invisible whispers traveling across unimaginable distances. Whispers made not of air and breath, but of radio waves, of electromagnetic pulses, of energy rippling outward from distant suns and spinning neutron stars, and events so vast and powerful we have no real words for them. Pause. The universe is speaking, very quietly, in a language we are still learning to read, and tonight we are going to listen together. Long pause. Part 2. The radio telescope and the quiet sky. Let us walk a little further now. Not away from the hillside, but deeper into it. Deeper into the night. Deeper into that feeling of peace and quiet wonder. Imagine another place now. A wide, flat plain somewhere in the American state of West Virginia. A valley so quiet that the United States government has designated it a National Radio Quiet Zone. a real place, a real designation, where radio transmissions are strictly limited, where even some types of Wi-Fi are restricted, because the instruments here need the sky to be as silent as possible. This is the Green Bank Observatory, and at its center, the Green Bank Telescope, one of the largest movable radio telescopes in the world, stands in the darkness like a great white flower turned toward the stars. Its dish is enormous. If you stood at its base and looked up, you would feel very small indeed, the way you feel small standing at the edge of the ocean or at the foot of a mountain range. But it is a gentle smallness, a peaceful smallness. Pause. The telescope moves so slowly you can barely perceive it, silently rotating, tilting, listening to different patches of sky, collecting invisible waves that have traveled for years, for decades, for millions of years, to arrive here at this quiet valley in West Virginia on this particular night. Somewhere in the control room, instruments glow softly. Data streams across screens in pale lines and numbers. A scientist sits quietly, watching. Perhaps she has a cup of tea going cold on the desk beside her. Perhaps she is very tired. Perhaps she has been doing this for many years, turning up to the observatory night after night, trusting the instruments, watching the data, waiting for something. Pause. What are they waiting for? We will get to that, very gently, very slowly. For now, just rest in the image, the wide plain, the great white dish, the quiet night, the infinite sky above, absolutely full of signals we are only just beginning to understand. Long pause. Radio astronomy, the practice of listening to the universe with instruments designed to detect radio waves, is not a new science. It began almost by accident in the early 1930s. A young engineer named Karl Jansky was working for Bell Telephone Laboratories, trying to understand the sources of radio noise that interfered with transatlantic phone calls. He built a large rotating antenna. People called it his merry-go-round. And he began to map the sources of interference. He expected to find things like thunderstorms, human-made noise, the usual culprits. But he found something else. A persistent, steady hiss, rising and falling on a cycle of about 24 hours. At first, he thought it might be the sun, but over time, he realized the signal was coming from a slightly different direction each day, moving slowly across the sky in a way that matched the rotation of distant stars rather than the movement of the sun. It was coming from the center of our own galaxy. Pause. The Milky Way itself was humming. Jansky published his findings in 1933. The scientific community was intrigued, but for a time, not many followed up on it. It was a lone radio amateur, an engineer named Grote Reber, working in his backyard in Wheaton, Illinois, who built his own radio telescope and spent years carefully mapping the radio sky, producing the first radio maps of the galaxy, largely on his own, in his spare time. He would work during the night. The neighbors thought he was perhaps a little unusual. Pause. We owe a great deal to people like that. The quiet ones, the patient ones, the people who turned antennas toward the sky in the middle of the night, not because anyone asked them to, but because the universe seemed to be saying something, and they wanted very much to hear what it was. Long pause. Part 3. A journey into deep space. Let us leave the observatories for a moment. Let us travel. In your mind, I want you to imagine yourself lifting gently off the ground. Not with any rush or force, just slowly, softly, as if gravity has decided to be kind to you tonight and has simply loosened its hold, and you are drifting upward the way a soap bubble drifts in a gentle breeze. You rise above the hillside, above the observatory, above the valley with its great white telescope dish. You rise through the cool night air, through the thin cloud that drifts at the edges of the atmosphere, and then, very peacefully, through the upper atmosphere itself, where the air becomes so thin it is barely there at all. And then you are in space. Pause. It is very quiet here. The stars, which from Earth seem to twinkle and shimmer, are perfectly still from here. No air to scatter their light. They are just points, pure, steady, eternal points of light. In every direction you look, above you, below you, to every side, a sphere of stars all around you. The Earth floats below, turning slowly. You can see the curve of the horizon lit softly by the sun on one side, the darkness of night on the other. Somewhere down there, all those observatories are still running, all those telescopes still turning, all those scientists still watching their screens. Pause. You drift further, further from Earth, past the moon, which hangs in the darkness like a pale lantern, beautiful and still and very far from anywhere. Past the orbit of Mars, that faint reddish dot in the distance. Past the asteroid belt, a sparse scattering of dark rocks tumbling slowly in their long orbits around the sun. Past Jupiter, enormous and serene, wrapped in its soft bands of orange and cream, its great storm system swirling slowly, patiently, as it has been swirling for hundreds of years. Pause. Further still. Past Saturn, with its rings tilted at their gentle angle, catching the distant sunlight and turning it into something that should not be as beautiful as it is, but cannot help being beautiful anyway. Past Uranus, palest blue-green, rolling on its side through the dark. Past Neptune, deep blue, at the very edge of the sun's family. And then, out, beyond the planets, into interstellar space. Long pause. Here, things are very different. The sun, which from Earth seems so enormous, so overwhelming, is just a star here. A bright one. The brightest in the sky by far from this vantage, but a star. One star among an uncountable field of others. The distances between things here are almost impossible to hold in your mind. The nearest star system to our own, Alpha Centauri, a warm triple star system, is about 4.2 light-years away. That means the light from those stars, traveling at 186,000 miles per second, takes 4 years and 2 months to cross the gap between there and here. 4 years. For light. Pause. The spacecraft we have ever built, the fastest things humanity has ever sent into space, would take more than 70,000 years to cover that same distance. Space is, in the quietest possible way, almost incomprehensibly vast. And yet, here is the thing that deserves a slow breath and a moment of reflection. The universe is also not empty, not even close. Pause. There are, by the best estimates of modern astronomy, somewhere between 200 billion and 2 trillion galaxies in the observable universe. Each galaxy contains, on average, hundreds of billions of stars. And we now know, thanks to missions like the Kepler Space Telescope, that most stars have planets. Most, not some. Most. The number of planets in the observable universe is almost certainly in the septillions. A septillion. That is a 1 followed by 24 zeros. Pause. And so, floating here in the silence between stars, drifting gently through the vast dark, it is natural, it is perhaps inevitable, to find yourself wondering, on how many of those planets, circling how many of those stars, in how many of those galaxies, is there something? Is there someone? Is there another consciousness, somewhere out there in this enormous quiet universe, lying in the dark and looking up and wondering the very same thing about us? Long pause. Part 4. The question that has always been asked. Human beings have been asking this question for a very long time. Long before telescopes existed, long before we even knew that other stars were suns like our own, long before we knew the Earth moved at all, people looked up at the night sky and asked, "Are we alone?" The ancient Greeks discussed the possibility of other worlds. Epicurus, the philosopher, wrote in around 300 BCE that it would be absurd to think only one Earth could exist in an infinite universe. Giordano Bruno, an Italian friar living in the 16th century, speculated passionately that the stars were other suns, each perhaps with their own worlds and inhabitants. He said this at a time when it was not entirely safe to say such things, and he paid a price for his ideas. But the idea never went away. Pause. As telescopes grew more powerful, and as we began to understand more about the size of the universe, its true, almost ridiculous vastness, the question only became more pressing, and more interesting, and more, in some ways, deeply personal. Because the question of whether we are alone is not just a question about astronomy. It is a question about meaning, about significance, about what it means to be alive and aware in this universe, on this small rocky world, orbiting this particular star. If the universe is empty, if life arose here and only here by some extraordinary stroke of chance, then what does that mean? And if it is not empty, if life has arisen in many places, if there are other minds out there listening to the same silence, then what does that mean? Pause. These are questions we perhaps cannot fully answer tonight, or ever. But they are beautiful questions. Gentle questions, really, when you sit with them quietly. They do not need to frighten us. They can simply accompany us, like the sound of rain on a roof, like the feeling of starlight on your face. Let them rest with you tonight, softly as we continue our story. Long pause. Part 5. The Birth of SETI. In the 1950s and 1960s, the question of other life in the universe began to be asked in a new way. Not philosophically, not theologically, but scientifically, systematically. A young astronomer named Frank Drake was working at the National Radio Astronomy Observatory in Green Bank, West Virginia. Yes, the same Green Bank we visited earlier. He was thoughtful and curious, and he had been thinking about radio waves. Radio waves travel at the speed of light. They can travel through the vacuum of space more or less unimpeded. They are something that any civilization with a certain level of technology might be able to produce and detect. If there were other civilizations out there, other technological civilizations, might they not be producing radio signals? And might those signals not be reaching us, even now, mixed in with the natural radio whispers of the cosmos? Pause. In 1960, Frank Drake pointed a radio telescope at a star called Tau Ceti, and then at a star called Epsilon Eridani, two nearby sun-like stars, each only about 11 light-years away, and listened. He called this project Ozma, after the princess of the land of Oz in L. Frank Baum's stories, a faraway, mysterious, fantastical place. It seemed a fitting name. He found nothing definitive. There were no clear signals from another civilization. But the project was not a failure. It was a beginning. It proved that this kind of search was possible, that it was a real scientific endeavor, not a fantasy. Pause. A year later, in 1961, Drake organized a small meeting, a gathering of some of the most thoughtful scientists of the era, to discuss the possibility of extraterrestrial intelligence. At that meeting, to help structure their discussion, he wrote on a blackboard an equation. It became known as the Drake equation, and it is perhaps the most famous equation in the history of astronomy, even though it contains numbers we still largely do not know. The equation attempts to estimate the number of active, communicating civilizations in our galaxy by multiplying together a series of factors: the rate at which stars form, the fraction of stars that have planets, the fraction of those planets that could support life, the fraction of those on which life actually arises, the fraction of those on which intelligence develops, the fraction of those that develop communication technology, and finally, the average lifespan of such a civilization. Pause. When you multiply all these factors together, you get a number. The question is, what is that number? Drake and his colleagues, making their best guesses with the knowledge available to them in 1961, came up with estimates ranging from 1,000 to 1,000,000 communicating civilizations in our galaxy alone. 1,000, 1,000,000. Somewhere out there, in the slow spiral arms of the Milky Way. Pause. Of course, we do not know how accurate those estimates are. Some scientists today think the number might be much smaller. Others think it might be larger still. The honest answer is that we do not know. We are guessing, carefully and thoughtfully, but guessing nonetheless. And the guessing itself is beautiful. Sitting with uncertainty, with wonder, with the possibility of something extraordinary hiding in the dark between the stars. There is something deeply peaceful about that, if you let yourself feel it that way. Long pause. The search for extraterrestrial intelligence, what became known as SETI, grew slowly from those early days. More scientists joined. More telescopes were pointed at the sky. More data was collected and analyzed. The SETI Institute, founded in 1984 and based in California, became one of the leading organizations in this work. Today, scientists there use some of the world's most sensitive radio telescopes, and increasingly optical telescopes as well, to scan the sky for signals that might not fit natural explanations, for patterns, for regularity, for something that speaks of intention. It is patient, quiet work. Most nights, nothing unusual is found. The universe hums along in its natural way, pulsars spinning, gas clouds radiating, the background hiss of the Big Bang itself still echoing softly through everything. Pause, and still they listen. Because one night, in 1977, something very unusual happened. Long pause. Part 6, the wow, signal. Let us drift back to Earth for a moment, to Ohio, to a warm summer night in August 1977. At the Ohio State University Radio Observatory, a facility affectionately known as Big Ear because of the shape of its antenna, a radio telescope was quietly scanning the sky. This was part of an ongoing SETI project, one of the most dedicated in the world at the time. Night after night, Big Ear swept across the sky, recording data on computer printouts. Most of what it recorded was, as expected, unremarkable, the ordinary noise of the cosmos. But on August 15th, 1977, something happened. Pause. At 11:16 p.m. Eastern Time, Big Ear's instruments detected a radio signal of extraordinary strength. It came from the direction of the constellation Sagittarius, toward the center of our galaxy. That same warm, crowded center where Carl Jansky had first heard the hum of the Milky Way almost half a century before. The signal lasted for 72 seconds, exactly the length of time an object in the sky could remain in Big Ear's field of view as the Earth rotated. It appeared, it peaked, and it faded, perfectly following the pattern you would expect from a signal coming from a fixed point in space. It arrived on a frequency very close to 1,420 megahertz, a frequency that astronomers had long theorized might be significant, because hydrogen, the most common element in the universe, naturally emits radio waves at almost exactly this frequency. If there were other civilizations out there, and if they wanted to send a signal that any radio astronomy capable society might notice, broadcasting near the hydrogen frequency would be a sensible choice. A kind of cosmic hello. Pause. The signal sat in the data printouts for several days, unnoticed. Then an astronomer named Jerry Ehman reviewed the printouts, and when he saw the signal, when he looked at the numbers climbing and then receding in exactly the pattern a real, strong, narrowband extraterrestrial signal should follow, he was so astonished, so struck by what he was looking at, that he circled it with a red pen and wrote a single word in the margin. Wow. Pause. And that is how it has been known ever since, the wow signal. Astronomers have pointed telescopes at that patch of sky many, many times since 1977. They have listened very carefully. They have used different instruments, different frequencies, different times of year. The signal has never been detected again. We do not know what it was. Pause. There are natural explanations that have been proposed over the years. Perhaps it was a comet, and hydrogen gas trailing from the comet produced a brief burst of radio emission at just the right frequency. Perhaps it was some unusual atmospheric phenomenon. Perhaps it was interference from a human-made source. But none of these explanations fit the data perfectly. None of them account for all the characteristics of what Big Ear detected on that warm August night. The most honest answer, even now, nearly 50 years later, is simply, we do not know. Pause. And there is something quietly wonderful about that. Something worth sitting with gently in the dark. In 1977, on a warm Ohio night, something sent a radio signal that was remarkable enough to make a scientist circle it in red ink and write "Wow" in the margin of a printout. And we still do not know what it was. The universe, it seems, does not always give up its secrets easily, but it does occasionally whisper. Long pause. Part 7. The Natural Music of the Cosmos. Now, here is something important to understand, and I want to share it with you gently as a thing of beauty rather than a complication. The universe, entirely on its own, without any help from alien civilizations or mysterious intelligences, produces an astonishing variety of radio signals. The cosmos is not quiet, not in the electromagnetic sense. It is full of voices, natural voices, the voices of physics, the voices of stars and clouds, and the remnants of ancient explosions. And sometimes these natural signals are so extraordinary, so unexpected, so apparently regular and structured, that when they are first discovered, scientists genuinely wonder, could this be artificial? Could something out there be producing this on purpose? Let me tell you about one of the most beautiful such moments in the history of radio astronomy. Pause. In 1967, a young doctoral student named Jocelyn Bell Burnell was working at the Mullard Radio Astronomy Observatory in Cambridge, England. She had helped build a new radio telescope, a sprawling array of antennas spread across several acres of countryside. And she was the one who spent hours every day analyzing the paper chart readouts the telescope produced. Hundreds of feet of paper per day. Scrolling through it by hand, marking radio interference from human sources, carefully noting anything unusual. In August of 1967, she noticed something. Pause. A small patch of sky that was producing a very peculiar signal. Not the usual steady hiss of interference or the gradual rise and fall of a known radio source. This was pulses, very regular pulses, coming every 1.3 seconds, like a heartbeat. She and her supervisor, Anthony Hewish, were initially puzzled enough by the regularity of the signal that they considered briefly whether it might be artificial. They even nicknamed it, with gentle humor, LGM1, for Little Green Men. Pause. But very quickly, as more analysis was done, it became clear that this was not a message from an alien civilization. It was something far stranger in its own way. A natural phenomenon that the universe had been producing all along, waiting for someone to notice it. It was a pulsar, a rapidly rotating neutron star, the dense remnant of a massive star that had exploded in a supernova, spinning so fast and so evenly that it swept a beam of radio emission across the sky like a lighthouse beam, producing a perfectly regular pulse every time it came around. Pause. Pulsars are extraordinary objects. Some of them spin hundreds of times per second, faster than a kitchen blender. They are made of material so dense that a teaspoon of pulsar material would weigh billions of tons on Earth. They are among the most extreme objects in the known universe, and they produce radio signals so regular that they rival atomic clocks in their precision. Jocelyn Bell Burnell's discovery opened up a whole new field of astronomy. Her supervisor won the Nobel Prize for it, a source of considerable controversy, given that she was the one who actually found it. But that is a story for another time. Pause. The point for tonight is this. The universe is full of things that sound, at first, like they might be signals from someone. Regular pulses, patterns, rhythms. The cosmos hums with structure, with organization, with behavior that follows laws so consistent they produce signals of remarkable regularity and beauty. This is not because the universe is being directed by an intelligence outside itself. It is because the universe operates according to rules, the rules of physics, that are, in their own quiet way, deeply orderly. And that orderliness is its own kind of miracle, its own kind of wonder. Long pause. Part 8. Fast radio bursts, the new mystery. If pulsars were the great mystery of the 1960s, and the wow signal was the great mystery of the 1970s, then perhaps the great mystery of more recent times is something called fast radio bursts. Let me tell you about them, very gently, because they are genuinely extraordinary. Pause. Imagine you are monitoring a radio telescope's data, not in real time, but reviewing archived data from an older telescope survey. This is what astronomer Duncan Lorimer and his student David Narkovich were doing in 2007, looking through data that had been collected by the Parkes radio telescope in Australia several years earlier. And in that old data, they found something that had been quietly waiting to be noticed. A single, extraordinarily bright pulse of radio emission, lasting only a few milliseconds, a few thousandths of a second, incredibly intense, and then gone. The pulse had characteristics suggesting it had traveled an enormous distance, possibly billions of light years, before arriving at the Parkes telescope. Pause. This became known as the Lorimer burst, the first detected fast radio burst. At first, many astronomers were skeptical. Perhaps it was interference. Perhaps it was something local, some terrestrial effect producing a fake signal. Radio telescopes are sensitive instruments, and they can sometimes pick up all kinds of unexpected noise from nearby sources. But then, slowly, over the following years, more fast radio bursts were found. In other data, from other telescopes, from different parts of the sky, arriving from different directions, with different characteristics, but all sharing that same signature. Extraordinarily brief, extraordinarily bright, apparently coming from cosmological distances, from billions of light years away. Pause. Some of them even repeat. They come back. A source in a distant galaxy will produce one of these brilliant millisecond pulses, and then another, and then another, sometimes weeks apart, sometimes months, sometimes in rapid sequences. We still do not fully understand what produces fast radio bursts. The leading scientific explanations involve magnetars, a type of neutron star with an extraordinarily powerful magnetic field, capable of producing brief but titanic releases of energy. There are other candidates too: merging neutron stars, exotic objects called cosmic strings, interactions between black holes. Pause. What we are quite confident about is that fast radio bursts are not, in the current scientific view, likely to be signals from alien civilizations. The energy required to produce them, the sheer staggering power of these events, argues for natural astrophysical processes rather than technology. A civilization capable of producing signals that intense and broadcasting them in all directions would be a civilization of a kind we can barely imagine. Pause. But here is what I find beautiful about fast radio bursts, even setting aside the question of their origin entirely. They are real. They are detected. They are being studied. Every year, more of them are found. Telescopes like CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a remarkable array in British Columbia designed almost like a series of great ski jump ramps, are detecting them regularly, cataloging them, beginning to understand their distribution across the sky. The universe, it turns out, is periodically sending us these brief, brilliant pulses of radio energy from billions of light years away. We are, right now, in the early days of understanding what they mean. Pause. There is a great library out there written in radio waves, and we are just beginning to learn to read it. Long pause. Part 9. Water and the Search for Life. Let us drift for a moment away from radio signals and telescopes and think about something more intimate, more earthly in a way. Water. Pause. One of the most striking things that modern astronomy has shown us is how common certain key ingredients for life, as we know it, are throughout the universe. Water, for example. That simple, extraordinary molecule, 2 hydrogen atoms and 1 oxygen atom, is not rare in the cosmos. Far from it. Water has been found in molecular clouds drifting between stars. Water ice has been found on Mars, on the moons of Jupiter and Saturn, in comets, in asteroids. There is evidence of liquid water beneath the icy surface of Europa, one of Jupiter's moons, and likely beneath the surface of Enceladus, a small moon of Saturn that actually shoots plumes of water ice into space from cracks in its southern pole. Pause. And organic molecules, the carbon-based building blocks of chemistry that is compatible with life, are also surprisingly widespread. Complex organic molecules have been found in meteorites, in interstellar clouds, in the regions of space surrounding forming stars. The raw materials for life, it seems, are scattered throughout the galaxy. Whether life itself arises from those materials easily, or only under extraordinarily rare and specific circumstances, we do not know. That remains one of the most important unanswered questions in science. Pause. But the discovery that so many of life's ingredients are so common has, over the decades, shifted the scientific community's intuitions. Many researchers today believe that life, perhaps very simple, microbial life, is likely widespread in the universe. that given enough time, the right conditions, and the right chemistry, life tends to happen. Intelligence, language, technology, that may be another matter entirely. That may be far rarer. But life, simple life, microbes in the dark, in the warmth of a deep-sea vent on some distant moon. Perhaps, pause. We do not know yet. We may find out within some of our lifetimes if we are lucky. There are missions planned, and some already underway, to look more carefully at Europa, at Enceladus, at other promising locations in our solar system and beyond. The James Webb Space Telescope, launched on Christmas Day 2021, is already beginning to analyze the atmospheres of exoplanets, planets orbiting other stars, looking for chemical signatures that might hint at biological processes. Pause. It is slow work, patient work, the kind of work that requires years and decades to yield its answers. But it is being done, carefully, quietly, by people who have given their professional lives to these questions, who sit in observatories and at computer screens and in laboratories, piecing together a picture of the universe's chemistry, one data point at a time. Long pause. Part 10. The Fermi Paradox, held gently. There is one more idea I want to share with you tonight. One more quiet puzzle to let drift through your mind as you settle towards sleep. It is called the Fermi Paradox. Pause. In 1950, the physicist Enrico Fermi was having lunch with some colleagues at Los Alamos National Laboratory. They had been discussing the possibility of extraterrestrial civilizations, a topic that was in the news at the time, as it often is. And at some point during the conversation, Fermi asked a question, a very simple question. But where is everybody? Pause. What Fermi was pointing to was this. If the universe is very old, and it is about 13.8 billion years old, and if the Milky Way alone contains hundreds of billions of stars, and if many of those stars are far older than our own sun, then there has been an enormous amount of time for civilizations to arise, to develop technology, potentially to expand and spread. Some scientists have calculated that a civilization with the motivation and the technology to do so could theoretically colonize the entire Milky Way galaxy within a few million years, which sounds like a long time, but is actually quite brief compared to the age of the galaxy. So where are they? Why do we not see any evidence of this? Why does space seem so quiet, so empty, so unmarked by any obvious civilization? Horse. This tension between the seemingly high probability that civilizations should exist and our complete lack of evidence for any of them is what we call the Fermi Paradox. And there are many, many proposed resolutions to it. Each one carries its own quiet poetry. Pause. Perhaps civilizations tend to destroy themselves before reaching the stars. Perhaps the transition from a simple industrial civilization to a truly spacefaring one is so difficult, so fraught with peril, that most societies fail to make it. Perhaps we are the first, or among the very first, to reach this particular stage, and all the others are far behind us in their development. Perhaps intelligence itself is extraordinarily rare. Not just technological intelligence, but any kind of complex, aware intelligence. Perhaps the step from simple microbial life to something that can look up at the stars and wonder is a step so improbable that it has happened only once, or only a handful of times, in a galaxy of hundreds of billions of suns. Pause. Perhaps civilizations that survive long enough to become truly advanced simply stop broadcasting in ways we can detect. Perhaps they use technologies we cannot imagine, forms of communication so far beyond our current understanding that our radio telescopes are simply the wrong tool for the job. Like trying to detect a cell phone call with an 1890s telegraph receiver. Perhaps they are there. Perhaps they are listening, and they are waiting patiently, as the universe is patient, for us to become something they are ready to greet. Pause. Or perhaps, and this is the thought I find most quietly beautiful, most worth holding in the soft space between waking and sleeping, perhaps we are early. Perhaps the universe is still very young in the sense that matters most. Perhaps most of the stars that will ever exist have not yet been born. Perhaps the great flowering of life and mind in the cosmos is still mostly ahead of us, billions of years from now, in a future none of us will see. Perhaps we are among the first to look up and ask these questions, and that is not a lonely thought. It is an extraordinary one. Long pause. Part 11. Messages we have sent. There is something I have not yet mentioned, and it feels important to share it before we begin to drift toward sleep. We have not only listened, we have also spoken. Pause. In 1972 and 1973, NASA launched two spacecraft called Pioneer 10 and Pioneer 11. They were the first human-made objects designed to travel beyond the solar system, to journey out past the planets, past the reach of the sun's gravity, into interstellar space. And on each of them, attached to their sides, was a small gold anodized aluminum plaque, about 9 inches by 6 inches, designed by Carl Sagan and Frank Drake, illustrated by Sagan's wife, Linda. Pause. The plaques show a man and a woman standing beside a simple diagram of the spacecraft itself. The man's hand is raised in greeting. Behind them, the spacecraft is shown in silhouette for scale. There is a map of our solar system showing the spacecraft's trajectory, its path of origin. There is a depiction of the hydrogen atom, that universal language. There is a diagram showing our sun's position relative to 14 pulsars, those spinning neutron stars we talked about earlier, each one labeled with its precise rotation frequency, so that any civilization that found the plaque and understood pulsar timing could, in principle, triangulate our location in the galaxy. Pause. Pioneer 10 is now the farthest human-made object from Earth, somewhere beyond the orbit of Neptune, drifting on into the vast dark. It would take about 2 million years to reach the nearest star. If it arrives there, if any remnant of it survives the journey, and if someone is there to find it, they will know that we existed, that we were here, that in the year 1972, we reached out our hand in greeting. Pause. In 1977, the same year as the WOW signal, as it happens, the Voyager probes were launched, and each one carried something even more elaborate: the Golden Record, a 12-inch gold-plated copper disc. On it, Encoded in the grooves are sounds and images from Earth. 115 images. Natural sounds. Surf, wind, thunder, rain, a mother's first words to her newborn child. Music. 90 minutes of music from human cultures around the world, including Bach and Beethoven and Louis Armstrong and Blind Willie Johnson. Greetings in 55 human languages. A greeting in whale song. Pause. There is a cover on the record that explains, in diagrams, how to play it. It assumes a civilization that can work out the puzzle. If they can, they will hear Chuck Berry. They will hear a Navajo night chant. They will hear a piece of Azerbaijani folk music and a pygmy girl's initiation song and Japanese shakuhachi music. They will hear the sound of the Earth's surf breaking on its shores. They will hear us. Pause. Voyager 1 crossed into interstellar space in 2012. It is now, as of today, the farthest human-made object from the Sun. Traveling at about 38,000 miles per hour. In about 40,000 years, it will pass, not very close but relatively near, to a small star in the constellation Camelopardalis. It will carry the golden record with it. Drifting, patient, silent, a small message in a very large bottle, floating in an immeasurable ocean. Long pause. Part 12. Breakthrough. Listen and the modern search. The search for extraterrestrial intelligence has, in recent years, entered a new era. In 2015, a major new initiative called Breakthrough Listen was announced, backed by substantial private funding and dedicated to conducting the most comprehensive scientific search for extraterrestrial intelligence ever undertaken. It has access to some of the world's largest radio telescopes, including the Green Bank Telescope in West Virginia and the Parkes Telescope in Australia. It is surveying millions of stars and hundreds of galaxies in multiple frequency bands with unprecedented sensitivity. Pause. Alongside Breakthrough. Listen is Breakthrough Watch, focused on detecting planets in nearby star systems, specifically looking for Earth-like planets in the habitable zones of Sun-like stars, using both existing and future telescopes. And there is Breakthrough Starshot, a genuinely visionary project, still in development, that aims to eventually send a tiny fleet of gram-scale spacecraft, propelled by powerful lasers, toward the Alpha Centauri system. These probes, traveling at perhaps a fifth of the speed of light, could reach our nearest stellar neighbor in about 20 years. Pause. They would not be able to slow down. They would flash through the Alpha Centauri system in moments and transmit their observations back to Earth at the speed of light. Those observations would take 4 years to arrive, but they would arrive. We would, for the first time in human history, have visited another star system. Pause. All of this is very new. All of this is happening now, in our lifetimes, in the early decades of the 21st century. We are living at an extraordinary moment in the story of humanity's relationship with the cosmos. The tools we are building, the questions we are asking, the data we are gathering, all of it is unprecedented. All of it carries the possibility of discovery on a scale that would change everything. Pause. And yet it is also, in its daily reality, quiet work, patient work, scientists at keyboards in the middle of the night, data flowing across fiber optic cables from telescopes on remote hilltops and plateaus. Algorithms sifting through oceans of information, looking for something that does not fit. Most nights, nothing is found. Most signals have mundane explanations. And most nights, that is perfectly fine, because the search itself is worth doing, and because the universe, as we have seen tonight, is under no obligation to reveal its secrets quickly. Long pause. Part 13. The Pale Blue Dot. Before we finish our journey tonight, I want to take you to one more place, or rather, one more perspective. In 1990, as the Voyager 1 spacecraft was racing outward through the outer solar system, the astronomer Carl Sagan persuaded NASA to do something unusual. He asked them to turn the spacecraft around and take a photograph, not of space ahead, but back toward where it had come from, back toward Earth. Pause. From 3.7 billion miles away, Earth appears in that photograph as a tiny dot, a pale, faint dot, barely visible against the darkness. It is smaller than a pixel, smaller than the resolution of the camera, really. It catches, just barely, a single scattered ray of sunlight, giving it a faint color. Pale blue. Carl Sagan looked at that photograph and wrote words that have traveled, perhaps, further even than the Voyager probe itself. Pause. He wrote about how everything we have ever known, every human being who has ever lived, every act of kindness or cruelty, every civilization and empire and religion and scientific discovery, all of it happened on that small, pale blue dot. He wrote about how we are, so far as we know, alone in the darkness. And he wrote that this teaches us something important, that our divisions are small, that our responsibilities to each other and to the thin biosphere of the only home we have ever known are large. Pause. Carl Sagan looked at that pale blue dot and found in it not despair, but responsibility and love. That image was taken in 1990. The Voyager 1 probe that took it continues, even now, to travel outward through the interstellar dark, carrying its golden record. If there is anyone out there, anywhere in this vast and silent universe, who finds that record someday, perhaps millions of years from now, they will know that on one small, pale, blue world, circling an ordinary star in an ordinary spiral galaxy, there were creatures who looked up at the sky, creatures who were afraid of the dark and also in love with it, creatures who sent music into the void. Long pause. Part 14. The Sound of the Universe. Let us end tonight with something soft, something that will carry you gently into sleep. The universe has a sound, not a sound you can hear with your ears, not the way you hear my voice right now, or the sound of rain or music, but a real vibration nonetheless, a real rippling of space and time. In 2015, scientists at the Laser Interferometer Gravitational Wave Observatory, LIGO, detected for the very first time gravitational waves. Pause. Gravitational waves are ripples in the fabric of space-time itself, the four-dimensional stage on which all of existence plays out. They are produced when massive objects move and accelerate, two stars orbiting each other, a black hole swallowing matter, and most powerfully, most dramatically, two black holes or neutron stars spiraling together and merging in a collision that releases more energy in an instant than the sun will release in its entire lifetime. When two black holes merged, 1.3 billion light-years away, the ripple they produced in space-time eventually reached Earth, and the instruments at LIGO detected it. Pause. When scientists converted that signal into sound, into a range our ears could detect, it sounded like a brief chirp, a rising tone, just over 1/10 of a second long. It has been compared to the sound of two black holes singing briefly as they become one. The universe chirped from 1.3 billion light-years away, and we heard it. Since then, many more gravitational wave events have been detected. Neutron-star mergers, more black hole collisions. The sky in gravitational waves is full of these distant songs. Pause. There is also the cosmic microwave background, the faint glow of radiation left over from the Big Bang itself, 13.8 billion years ago. It fills the universe in every direction, uniformly, like a perfect bath of warmth. We can detect it with our instruments as a low, soft signal in the microwave range. This is the oldest light in the universe. Light that was produced when the universe was only 380,000 years old. A newborn, still opaque with heat and energy, not yet transparent. When astronomers map the tiny variations in this ancient glow, they can read the structure of the very early universe, the seeds of the galaxies and clusters and great cosmic webs that eventually formed. Pause. If you translated the cosmic microwave background into sound, as some scientists and musicians have done, as an exercise, it would be a very low, very slow hum. The fundamental note of the universe, the sound of the Big Bang, still echoing, still echoing. Long pause. Part 15. Coming home to sleep. And now, dear listener, it is time to come home. Time to let the universe recede, gently, back to its proper distance. Time to let the stars become simply the stars, beautiful and remote and full of their quiet mysteries, which will wait for us. They are patient. They will be there tomorrow night and the night after, and for billions of years to come. Pause. You have traveled far tonight. You have stood on a hillside and looked up at the Milky Way. You have sat in the quiet control room of a great radio telescope, listening to the sky. You have drifted through the outer solar system, past planets wrapped in their rings, past moons hiding oceans under their ice. You have heard about the wow signal, that strange, brief, still unexplained radio whisper from the direction of the galaxy's center on a warm night in 1977. You have learned about fast radio bursts, those brilliant millisecond flashes arriving from billions of light years away. Still mysterious, still beautiful. You have thought about the question, held it gently, turned it over in your mind, of whether we are alone. And you have found, perhaps, that it is not a frightening question. Not in the dark, not when you are warm and safe. It is simply a large and interesting question. A question the universe holds open, generously, like a door left ajar into a room you have not yet been inside. Pause. The scientists of the SETI Institute will go on listening tomorrow. and the night after. And the telescopes will keep turning, and the data will keep flowing. And somewhere, in some archive, some pattern may be waiting to be noticed, waiting for the right person to look at the right data at the right moment, the way Jerry Amon looked at a computer printout in 1977 and reached for his red pen. Or perhaps not. Perhaps the signal, when it comes, will be nothing like what we expected. Perhaps it will arrive from a direction we were not looking, on a frequency we had not thought to monitor, in a form we had not imagined. Pause. Or perhaps it will not come at all. Perhaps this pale blue dot is, after all, alone in a very large and beautiful universe. Either possibility is, in its own way, astonishing. Either possibility is worthy of all the patience, all the listening, all the quiet work that thousands of scientists have dedicated their lives to. Pause. The universe, as we said at the beginning of our journey, is speaking, very quietly, in a language we are still learning. We are still early in the learning, and that is all right. Long pause. Part 16. The slow drift to sleep. Let us be very quiet now. The observatory on the hillside is dark, except for the soft glow of monitors inside. The great telescope dish still turns, but very slowly now. The night nearly over, the sky beginning, somewhere on the eastern horizon, to show the first pale suggestion of dawn. The scientist has gone home. The teacup has been washed and set to dry. The data from tonight's observations is stored safely, waiting to be reviewed tomorrow. Pause. In West Virginia, in the deep, quiet zone, the Green Bank telescope stands still in the early morning air. A bird calls somewhere in the valley below. One of the first birds, always the brave ones, the ones that start before the light has fully arrived. In California, at the SETI Institute, people are beginning to come in for the morning shift. Coffee is brewing. Conversations are starting. Another day of data will be gathered today. Another tiny piece of the vast puzzle. Pause. Out in space, in the enormous, silent dark between the stars, the Voyager probes drift on. They have been traveling for nearly 50 years now. They are the loneliest objects humanity has ever made, and they carry, each of them, that golden record, that message, that reaching out. The universe surrounds them, vast and quiet, and perhaps, just perhaps, listening. Pause. The stars above you tonight are the same stars that were above every human being who has ever lived. They were there before us. They will be there after us. They burn according to the laws of physics, which do not change and do not sleep. They are very old, and they are very patient, and in a way that is difficult to put into words, but easy to feel. They are with you, even here, even now, even as you close your eyes. Pause. You are made, as the scientists remind us, of stardust. Every atom of carbon in your body was forged in the heart of a star that lived and died before the sun was born. Every atom of oxygen in your breath came from ancient stellar furnaces. Every iron atom in your blood was created in a supernova, the death of a massive star billions of years ago. You are, in the most literal possible sense, a part of the universe. Not apart from it, a part of it. Pause. And so tonight, as you rest, as your breathing slows and your body grows heavy and the thoughts begin to soften and blur at their edges. You are not far from the stars. You are, in a quiet and real way, among them. Long pause. Part 17. Final drift. The night is very deep now. The stars have turned overhead, as they always do, the slow, patient turning of the earth carrying them across the sky, east to west. The same movement that has marked time for every creature that has ever looked up. Orion, perhaps, is setting in the west. The Pleiades following behind him, that soft, hazy cluster, like a tiny smudged handprint of stars, visible to the naked eye on a clear night. 7 stars in a tight formation that has been noted by human beings on every continent since before recorded history. Pause. The Southern Cross rises in its season for those in the Southern Hemisphere. That small, modest constellation that navigators have used for centuries to find their way at sea, to orient themselves, to know where home was even when land was out of sight. The North Star stands, as always, almost exactly above the North Pole. Patient, unwavering, every night, all night, in exactly the same place in the sky, a fixed point around which all the others seem to wheel. Pause. These stars are not going anywhere. They will be there tomorrow, and next week, and 100 years from now, when none of us are here to see them, they will still be burning with the same quiet intensity, turning their slow circles overhead. There is something deeply comforting in that permanence, something that feels, at this hour, like a kind of reassurance. Pause. The signals are still traveling through space as you read these words and settle towards sleep. The fast radio bursts are still pulsing from their distant galaxies. The cosmic microwave background radiation still fills the universe in every direction, that faint echo of the very beginning. Somewhere, perhaps, another signal is making its way toward Earth, maybe arriving in 1,000 years, maybe in 1,000,000, maybe tomorrow. We will not always be the only ears listening for it. Future generations will have better instruments, larger telescopes, faster computers, decades more of data, and they will stand at the edge of the same mystery and look into the same dark sky, and they will ask the same question. Are we alone? Pause. That question is perhaps one of humanity's most enduring inheritances. We pass it along, generation to generation, from Epicurus to Giordano Bruno, to Frank Drake, to Jocelyn Bell Burnell, to the students just beginning their doctoral work tonight in radio astronomy departments around the world. The question is not a burden. It is a gift. Pause. A gift that keeps us looking up, keeps us building better instruments, keeps us curious and humble and aware of how much we do not know, keeps us connected to the night sky, to the oldest thing human beings have ever looked at, the most enduring source of wonder our species has ever known. Long pause. Part 18. The last light. The last light of tonight's journey. You have come a long way, from the hillside with its soft grass and cool air, through the control rooms and the observatories, out past the planets and into the interstellar dark, back through time to the Big Bang, and forward again to the missions being planned even now. You have held the wow. Signal in your mind that gentle red-circled mystery from 1977. You have imagined the golden record drifting through the dark on its Voyager vessel. You have pictured the Green Bank telescope, white and enormous and patient in its quiet valley. You have thought gently about the question that human beings have been asking since they first lit fires and looked up at the night and wondered what else was out there. Pause. And now it is time to rest, to let the questions drift, the way dust drifts in a beam of sunlight. Not gone, never gone, but not pressing, not urgent, just floating quietly in the air of a peaceful room. The stars will do their work tonight. The telescopes will go on turning. The universe will go on being vast and old and full of signals traveling in all directions, carrying information about events that happened before Earth existed, before the sun was born. Pause. You do not need to solve any of it tonight. You do not need to do anything tonight at all. Just breathe. Pause. In, pause, and out, pause. The room you are in is warm and quiet. Your body is settled and still. Your mind, which has traveled so far tonight, past Jupiter, past the edge of the solar system, past the boundaries of the known, can rest now. It has done enough. Pause. Somewhere very far away, a radio telescope is pointing at a patch of sky near the constellation Sagittarius, listening patiently. Somewhere even farther away, a small battered spacecraft with a golden record strapped to its side is drifting through the dark between the stars. And somewhere farther still, perhaps, something is out there, under a different sky, under different stars, perhaps also resting, perhaps also in some way we cannot imagine wondering. Are we alone? Pause. We do not know. Pause. We may never know. Pause. And that is a beautiful thing to carry into sleep. Not a worry, not a fear, just a wide and open and endlessly interesting question, left gently at the edge of your pillow to keep you company in the dark. Long pause. The stars are out tonight. They have always been out, and tomorrow night they will be out again. Pause. Sleep well. Pause. Sleep deeply. Pause and dream of starlight, all those ancient photons, traveling for millions of years across the dark, arriving at last at the back of your closed eyes. Pause. Good night. Long pause. End.